Welcome, class, to Lesson 6-4. Today, strong mathematicians can convert between mixed numbers and fractions greater than 1. So you take out your notebook, your pencil, write down today's date, the name of the lesson, and let's get started. So what is a mixed number? Well, a mixed number is a number that consists of a whole number and a fraction. So notice you might see it 3, and there's a little space in here, and there's our whole number, and this would be our fraction. Another way you might see it written might look like this, which is a little easier to see, would be 3 4/5, where you can see the whole numbers in front of the fraction which comes from behind it. I prefer this way, but unfortunately sometimes when you type it on a computer, it looks like that, and that's the best we can do. Here is 1 4/6, and 1 4/6. So if you try to do it this way, I'll try to make sure I put an emphasis on the space in between them so you can tell that it's a whole number and a fraction, not 14/6, which would be our next vocabulary word you should be writing down, which is a fraction that's greater than 1. Well, how can a fraction be greater than 1? What does that mean? It has a numerator that is greater than its denominator. So far we've always had the numerator has been smaller, but fractions greater than 1 look like that. So we have 11/6 would be one example. 19/15, the numerator. Both of these numerators right here are bigger than their denominators that are down here. So you can write down these notes to help you with what is a mixed number and some examples, and also what is a fraction greater than 1, so you can understand that when we see these and we see them in problems coming up. And with that, we're going to change each mixed number to a fraction. So now, we want them to be fractions. They're going to be fractions greater than 1 because these all have whole numbers. So how do we do this one? So if you think about what does this look like? We have 3 whole, and then we have 4/5. Well, that means if we have 3 whole, I'm going to draw a picture for this first one. I have 1, 2, 3, 4 pieces. Of these would have 5 parts. Now, fifths are so hard to draw. I don't know why I chose to draw it this way, because they should all be equal. Remember, fractions should be equal parts. But since I've already committed to drawing this, I'm going to just do my best to make do. And so they all have, whoops, that's not going to work so well. 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. So they'll have 5 parts. So what does 3 whole mean? Well, let me shade in each of these 3. So 3 whole would mean 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So if I would turn those in, 3 whole would equal 15/5 because each piece is a fifth. And I have 15 of them with my 3 wholes. I now have 4/5 from the other parts. That'd be 1, 2, 3, 4. So that gives me 15 plus 4 would give me 19/5. So that'd be a drawn out version of how I can figure out how many fraction pieces there are from a mixed number. Now let's see if we can look at this one and see if the next couple, see can we do it a little bit different so we don't have to draw them out, because it's not so bad, but if I got to draw like 6 and 5/8, that's a lot of pieces and a lot of things to draw out. Same with 7 and 3/7. So might there be an easier way to look at these numbers? Well, there is. So 7 whole is important. Also, the denominator is important. 7, that tells you how many pieces you're going to cut each whole into. So 7 times 7. Notice back at this problem, we did 3 times 5, which gave us, in the first 3, we had 15 pieces. So we have 49, and then what did we do? We added the numerator to it. So we have 7 times 7 is 49, plus the 3, so we have 7 times 7 would give us 49 sevenths, plus the 3/7, the numerator, is what's left over, which equals 52 sevenths. So you might be thinking, whoa, what's going on? There's a lot of things going on there. We'll walk through a few more examples to really help you out here. So let's take a look at the ones we have on the bottom. So 9 and 1/4. That means each part is cut into fourths. And I have 9 whole of them. So it would be 9 times 4. And then, after I do that, I can draw a little arrow with that part up here, and I'm going to add in my last part of +1. So I have 9 times 4 would be 36. So 36/4 would be what I have from my wholes, plus the 1/4 that I have left. Kind of like a remainder. As I talked about, sometimes a remainder can be in fractions, which would give me 37/4. And last but not least, 6 and 5 ace. Well, we're going to take 6 times 8 is 48 plus the 5. So we have 6 times 8 plus 5. If we follow order of operations, we do this part first. So we have 48 plus 5, which will give us 53. So we have equals 53 ace. So you can pause the video right now if you want to go back and re-watch this one to get a feel of how this works. This is kind of a big type of concept to help us go from mixed numbers to a fraction greater than 1. Uh-oh, reverse. Now we're going to go the other way. Wait a second, we just got good at the first way. Now you go back the other way? Well, how can we change from a fraction to a mixed number? Well, if we think about our inverse operations, if we multiplied the last time, here most likely we have to divide, which would be the undoing what we did. So if I have 13 pieces and I'm putting them in groups of 6, it would be 6 divided by 13. So 6 divided by 13 would be 2. 2 times 6 is 12, which would give me a remainder of 1. Now, how do I write this as a mixed number? This is the important part. So how many wholes do I have is 2, because I can make 2 whole groups of 6 from 13. So 2 is my whole number. My remainder is now going to be my numerator. That's how many pieces I have left over. So I have 1 piece left over, and my denominator is going to be my divisor. Denominator. So denominator, divisor, maybe that DD can help you out, and that will be a 6. So 13/6 is equal to 2 and 1/6. So we'll keep that up as an example. You can kind of pause and look at that and kind of analyze it, maybe rewatch this problem to get a feel for it before we try some of the other ones right now. So we got 25 pieces and each size is 1/8. So that means how many holes can we have? So we have 28 divided by 25, or 25 divided by 8. 8 can go to 25 3 full times. 3 times 8 is 24. 25 minus 24 is 1, so it gives me a remainder of 1. No, they will always not be a remainder of 1. Don't get excited. It happens to be 2 in a row. Call it luck. Call it bad planning. Call it what you want. So we have right now, how many holes do we have? Well, if we look back at our whole number is how many complete groups? That's going to be 3. Our remainder is our numerator, and our divisor is our denominator. So it would be 3 and 1/8 would equal 25/8. If you're feeling confident, we'll give it a shot. Pause right now. Try to see if you can do the bottom 2 and see if you can get them, and then compare your work to my work. So we have said, 40 divided by 7. 7 can go into 40 5 times. 5 times 7 is 35. We subtract. We're left with 5. Nothing to bring down. So we have a remainder of 5. See, I told you it's not always 1. Now, when we have that, the big part is, how do we write that? That's always the important piece of the puzzle, because you do the right work. If we put them in the wrong spots, we don't get the correct answer. So remember, this is my whole number. So 5 is my whole number. My remainder is my numerator. And my divisor is my denominator. Divisor, denominator. So I have 5 and 5/7 is equal to 40/7. And last but not least, 37 divided by 4. 4 can go into that 9 times. 9 times 4 is 36. With a remainder of 1. You're thinking, Mr. Kaming, a lot of 1s. Just crazy coincidental luck. What does that mean? 9 and 1/4. So really your remainder for any problem you've done before is really part of a whole. As in here, we have 1 part left of the 4 pieces. So we have 1/4. So 9 and 1/4 is equal to 37/4. So you can pause the video, write this important stuff down, rewatch this section if you have to really help you understand it better before you begin your own work. And with that, here we go. We're going to change each mixed number to a fraction. You have 4 of them to do, so make sure you write the mixed number first, and then your answer to show that they are equal. Good luck. And now we're going to do the same thing. We're going to take a fraction now and turn it into a mixed number. It's very important that we can go from one way to the other and back and forth and vice versa to really help us understand how fractions greater than 1 and mixed numbers are connected and related. And it's going to help us out in future lessons as well. So you can pause the video right now, and good luck. If you have any questions, comments, or concerns, feel free to write them down or share them out. Also, if you have any strategies that help you use, make sure you share those as well, because it's going to help other students. And once again, thank you for another great lesson.